Before we get started, I just wanted to give you a little background on Grantek. As you know, we're a system integrator and a solution provider with over 35 years experience. We have regional offices across North America, and here you can see some of the typical services that we provide on the plant floor. We provide services including packaging, controls and automation, industrial networking, MES integration, and as you can see, the rest are here. As you see, this includes most of the stuff that we do within your building. Outside of that, one of the areas where we help out with is coordinating with other plants and being able to drive corporate initiatives from your headquarters down to your plants and feeding that business intelligence back to them. We also do OEM coordination and supplier coordination. So when it comes to machine safety specifically, one of the values that we provide to our customers is that our heritage is not in physical guarding. Our heritage is in improving productivity and driving operational excellence. So when we look at machine safety, we're looking at it through the lens of improving productivity. So without further ado, I'd like to introduce today's speaker, Jeff Winter. Jeff is the director of Grantek Safety Practice, a division of the company that delivers safety-related services. His team is comprised of highly skilled safety experts that provide thought leadership to our clients. Besides earning his TÜV certification, CSP, Jeff is also very active within the safety community, especially as it relates to the development of safety standards. So before I hand this over to Jeff, I wanted to go over some logistics. This presentation is 45 minutes long, and please keep your questions to the end. Also, this presentation is being recorded and will be sent to you. With all that being said, I'd like to hand this over to Jeff. Jeff?
Thanks, Ash. Hello, everyone. Thanks for joining us today. So today's presentation is meant to help everyone learn more about the topic of lockout, tagout, and alternative methods. In doing so, we'll start with explaining some of the basics of lockout, tagout, and machine safeguarding. We'll also touch on the regulations and industry standards that support these topics. We'll then jump into the new Z244.1 Standard, and we'll even review a few examples to help give some guidance on how to move forward. Now, keep in mind, this is meant to only be an introduction to the topic. You'll need to gauge the maturity of your organization and determine where you may need more guidance and more education. From my experience, this image sums up what I run into the most with manufacturers. On one side, you have operations saying lockout is hindering production and causing unnecessary downtime. And on the other side, you have EH&S saying that lockout is the law of the land and the only way to keep people safe. Well, both these groups are pulling in opposite directions. This topic will forever be a tug of war. Hopefully with some education, especially today, we can all come to a middle ground by bridging these two topics, which would result in increased safety and productivity. Before jumping into any of the details of lockout tagout, and especially alternative methods to lockout tagout, we need to ensure that we have an agreement and solid understanding of the fundamentals. Going over the differences between machine safeguarding and lockout tagout may seem trivial or even too basic, but it's essential to understand their differences before we can talk about taking advantage of how they can work together. So what is machine safeguarding? Well, machine safeguarding is a precautionary safety feature on equipment comprised of devices and methods designed to protect employees from hazards created by the equipment while working nearby or while operating equipment. Oversimplified, keep people away. So what are the requirements in terms of machine safeguarding? Well, in the United States, OSHA establishes the minimum requirements for safety. OSHA was created in 1971, and in terms of machine guarding, it hasn't changed since. That means that these regulations are 46 years old. And I would hope that everyone on this call would agree that a lot has changed in the past 46 years, especially in terms of technology and the methods of protecting people with that technology. Just look at how the regulation for machine safeguarding is organized. It has two sections which apply to all machines, 1910-212, General Requirements, and 1910-219, which applies to gears, belts, pulleys, chains, and other transmitting mechanical energy apparatuses. The rest are machine-specific. And in today's market, we can use a lot more machines than are the ones listed here. So what's that mean? It basically means that for most manufacturing industries, we only use these two regulations, 212 and 219. To sum up the requirements of 212 and 219, it's the employer's responsibility to protect employees from hazards created by machinery. Basically, just guard the hazards. That's it. Make it so you can't get hurt. Easy, right? So then what is lockout tagout? Well, lockout tagout refers to specific practices and procedures to safeguard employees from the unexpected energization or startup of machinery and equipment, or the release of hazardous energy during service and maintenance activities. Oversimplified, remove hazardous energy. Now, most injuries can occur on machinery that do occur on machinery come from service and maintenance related activities and not from normal everyday use. And that should make sense to everyone, since service and maintenance tasks are the tasks that most likely put you in harm's way. So what are the requirements for lockout tagout? Well, in 1989, OSHA introduced 1910-147, the Control of Hazardous Energy, in order to establish lockout and tagout requirements for general industry. And as you can tell by that date, this regulation is significantly newer than the regulations for machine safeguarding. And as a bit of history, the OSHA regulation used the 1982 version of the Z244.1 Standard as a principal reference source. The industry set the best practices, and then years later, OSHA basically followed suit. So you're aware, if you were to print out the entire regulation, it's only about 13 pages. And in short, 1910-147 establishes minimum performance requirements for controlling hazardous energy. The regulation specifies that employers must establish an energy control program in order to ensure that employees isolate machines from their energy sources and render them inoperative before any employee services or maintains them. So where does lockout, tagout, and machine safeguarding intersect? The lines can be a little bit blurry, and defining these lines is where I personally spend most of my time educating others. If you have a particular machine you're looking to make safe, you'll need to apply both lockout, tagout, and machine safeguarding. They serve very different purposes, which is why they have different regulatory requirements. Yet, they're both essential to providing a safe machine. So lockout, tagout applies only to service and maintenance tasks, where the default go-to requirement is to lock out the machine by removing hazardous energy. Machine safeguarding applies to general use and normal production operations. Think about everything else that's not service and maintenance tasks, just making sure that any old employee or bystander does not get hurt by the equipment. A good visual might be to think of it as child-proofing the machine. So the go-to requirement here is to keep people away from the hazards through physical guarding or by adding safeguarding devices that either detect people entering an area that they shouldn't be entering or detecting them inside an area that they shouldn't be inside. In both cases, these devices must ensure that the machine enters a safe state. This safe state doesn't necessarily mean removing power, like the requirements of lockout tagout. That's where part of the confusion comes in. So as hopefully you're able to figure out, the main distinction between the two is based off the particular task at hand. Depending on what the employee is doing determines what type of protection should be used. Think of it like this. If the employee needs to do something to or with the machine, then the default is to lock it out. If a curious employee walks up to the machine and says, "Ooh, what's that?" and then goes to try and touch it and they can get hurt, that's where you need safeguarding. There are a lot of obvious tasks where lockout tagout makes sense, such as replacing a motor, but then there's a lot of others that don't really fit nicely into the requirements. That is where we enter the elusive space called the minor servicing exception. This term, minor servicing exception, is just an industry way of describing a small note in 1910-147 A2IIB. This one little note, which I'll read to you, it's what gives employers the ability to not apply the requirements of lockout tagout. It's extremely powerful, even though it's so short. It's one sentence. So I will read it for you. Minor tool changes and adjustments and other minor servicing activities which take place during normal production operations are not covered by the standard if they are routine, repetitive, and integral to the use of the equipment for production, provided that the work is performed using alternative measures which provide effective protection. See subpart O. Now, at first pass, that note may seem to make perfect sense and easy to apply, but this minor servicing exception has been one of the most controversial aspects of machine safety for many years. The devil's in the details. Defining what each of those underlying items mean and how they are determined can make or break your ability to claim this exception. Essentially, this exception allows employers an ability to use their general machine guarding, assuming it's adequate, as an alternative to lockout tagout for special set of tasks. According to OSHA's expectations, your machine safeguarding should already be adequate to protect employees for normal conditions. But what about when you use your safeguarding for the minor servicing exception? Can you claim your safeguarding provides effective protection during service and maintenance activities? That's something to keep in mind as we continue. As of February 2008, OSHA released an enforcement manual for 1910-147. This directive instructs OSHA enforcement personnel on both the agency's interpretation of the regulation as well as the procedures for enforcing them. This directive is 136 pages in length, with more than 25 pages just explaining how to enforce the minor servicing exception. That one little sentence I showed you earlier. This directive arms the inspectors with information to help determine if your lockout tagout program is compliant. It's a great source for understanding how the lockout tagout regulation is enforced, but it doesn't give a lot of guidance on how to develop a lockout tagout program, how to assess your equipment for hazards, identify hazardous energy sources, or determine what safeguarding measures might be acceptable for alternative methods to lockout tagout. To make an analogy, it's like getting a copy of the referee's field manual for football. It doesn't help you play football better, but it sure does help you know what the refs are looking for when they call a penalty. So you're aware, there is no equivalent directive for general machine guarding. What you see in the regulation is also what the OSHA inspectors have. Apparently OSHA inspectors and the industry in general find that machine guarding is easy enough and doesn't need further guidance. So now let's talk about industry consensus standards. If you choose to follow these standards, which are not required by OSHA, you are following what the industry has come together and agreed upon as the best method or solution for a particular topic. In terms of safety, these standards carry a tremendous amount of weight. You don't want to be caught explaining how you made something less safe than how the industry agreed was the best way to do it. Standards help take the guesswork out of determining what is right. More than anything, they provide clarity around a very subjective word, safety. What exactly is safe, or safe enough? Without standards, I bet a lot of money my definition of safe would be entirely different than yours. In addition, standards make it a lot easier to demonstrate compliance to the regulations. In general, applicable to our topic at hand, I found it easiest to break the available standards into the following categories. This is just my way of grouping the standards in a manner I think that helps make sense. So, we have assessment standards that help make sure you identify and remediate hazards appropriately. We have product standards that give you confidence that safety devices and technology are fail-safe and designed correctly. We have application standards that ensure safety devices and technology are applied, installed, and used properly. We have performance standards that ensure all safety systems, devices connected together essentially, are designed to still work in the event of a failure. We have validation standards that make sure all the pieces were put together properly to ultimately reduce the risk. In addition to these standard types, there are other standards, such as Z244.1, which tackle a specific topic and pull from all these standards to help support it. It's viewed as a simpler way of collecting all information together in one spot using these other well-established standards on the market. In America, ANSI facilitates the development of standards by accrediting the procedures of standard development organizations. In the case of machine safety, there's dozens and dozens of ANSI standards developed by multiple organizations such as B11, ASSE, RIA, and others. Each of these groups has a special area of expertise and is responsible for managing the development of their particular standard. So if you include international standards such as ISO and IEC, there are roughly 1,000 standards available to explain the best practices related to machine safety. Now, some of you may be thinking, oh my, that's obnoxious and that sounds like a waste of time. But another way to look at it is the wheel to your problem has already been invented by others. It's just a matter of searching for it and finding it. So you only need to find the handful of standards that apply to you. And trust me, they will help you answer questions so you don't have to spend time trying to figure them out yourselves. They save you time. In the case of Lockout Tagout, there is only one American industry consensus standard on the market, and that standard is ANSI ASSE Z244.1. So now let's start talking about that standard. Since 1973, the Z244 Accredited Standards Committee has been developing and revising the standard on control of hazardous energy. The first publication was in 1982, which was reaffirmed in 1992. 2003 was the last major revision to the standard, which was also reconfirmed in 2008 and 2014. Grantek joined the Accredited Standards Committee in 2014 and was a participant in the development of the new 2016 revision, which got released in December. With the increased use of risk assessments and advancing technologies, there are now conflicting views on the requirements for how and when to control hazardous energy, oftentimes causing employers to take the stricter route of locking out all the time. There is no disagreement on the basic principle that workers should be protected from unexpected startup or release of hazardous energy. However, there continues to be disagreement over how, when, and where requirements apply. The committee for the 2016 revision concentrated on how to control hazardous energy using methods based off current knowledge. The committee discussions changed from the focus of how do we meet OSHA instead to what's the right thing to do given current technology and industry best practices to protect workers. That's a big change in mentality and important to know. The 2016 revision presents distinct requirements for controlling hazardous energy through three different approaches: lockout, which has always been and still the primary approach, tagout, and alternative methods. Now, none of these categories of solutions are new, but they have been revised. Alternative methods have received additional attention to emphasize their importance in the energy control process, heavily relying on the need for risk assessments. Since this standard is designed to control hazardous energy in the best possible ways to protect employees, the approach towards solely catering to OSHA was rejected. That means that the artificially created concepts of normal production operation and servicing and maintenance, those delineations have been removed. By removing ourselves from the shackles of these arbitrary terms, the committee was able to develop entirely new guidelines for when lockout is required and when alternatives might be used. The standard now is way more task-driven than before. This is in contrast to the previous reliance on the type of activity being performed. Before, and according to OSHA, if it was a service and maintenance activity, it didn't matter what the task was. Lock it out. But there's this little exception that we'll give you that's going to be very difficult to acclaim to allow you to use alternative methods. But now, this standard helps provide much more ammunition to explain how each and every task is safe, regardless of what activity it falls into. The change in not catering to OSHA means that the standard hopefully will be more universally accepted and applied, not just by employers, but also machine builders and integrators. This also includes areas outside the United States. So let's go over what exactly is covered within the standard. Listed here are all the sections of the standard. The last revision only had 5 sections. This one has 8. That in itself shows you how the revision expanded. The standard went from 72 pages to 128 pages. The main meat of the standard is in sections 4 through 8, What I'm going to go over with you is not all the requirements, but the notable changes and important takeaways. Going over the standard in its entirety would take much longer than a lot of time. The first three sections are fairly boilerplate, so we're going to jump right into Section 4, Responsibilities. In general, the responsibility requirements are the same. However, the 2016 revision expanded the requirements for what they call supplier, which are machine builders, integrators, contractors, and even in-house engineering. Suppliers that follow this standard are now required to meet all the design requirements established in Section 5, which we'll go over next. That requirement is new. It's a new emphasis. In addition, the user now has much more clearly specified requirements around procuring safe equipment and ensuring all equipment is compliant with the standard. It actually now requires employers to develop a plan for addressing all of your existing equipment, not just new equipment. Now, the reason that that's in there is because you should already have an energy control program anyway. And remember, you can always default to lockout all the time. So, that being the case, as an employer, it may be worth considering the requirement that all of your suppliers, which as a reminder are machine builders, integrators, contractors, etc., that they follow this standard as a part of your corporate safety specifications. This single requirement can ensure that your new equipment that you're getting, or your capital upgrade projects when completed, will fit right into your energy control program. This is especially beneficial if you're buying equipment overseas, where lockout tagout is viewed much differently, and I guarantee you probably won't get what you expect. Requiring the standard solves that problem. As an example, if you hired Grantek to upgrade or modify a machine, even if it has nothing to do with safety, and you require that we meet this standard as part of the upgrade, we would be compelled to give you the documentation to ensure all of our modifications are not only safe for use, but we would also be compelled to tell you how these modifications fit into your lockout tagout program. Without it, you as the employer would be tasked with figuring that out on your own. So the question is, would having this information given by your suppliers, in this case Grantek, be valuable to your organization? The biggest section will affect suppliers is Section 5. The design requirements. This is where the engineers live. Remember, in the last version of the standard, this specific section was not really called out as the responsibility of the supplier. There's a lot of good stuff in this section based off of industry best practices. The single biggest change here is the requirement of a risk assessment before and during the design phase. Even though this should already be best practice today, Z244.1 now mandates it. Suppliers meeting this standard are now compelled to not only evaluate risks, but document them and provide justification for alternative methods. This requirement may add a tiny amount of cost to the project up front, but I guarantee it's going to save you a tremendous amount of money and time on the back end. By requesting this, you essentially hold the supplier, the experts on the equipment, accountable for giving you the information you need to justify your alternative methods to OSHA. You aren't obligated to follow the procedures provided by the suppliers, but at least you'll have the information you need to be armed and equipped. Related is the new additional requirements around other additional documentation, as you see listed here. As you can tell, this really emphasizes making sure that the supplier adequately documents decision and gives proper instructions. That's a big change. There's also additions to the use of warning labels, placards, and other special instructions located in the area of hazards to provide information to employees working on the equipment. Control integration has been revised to state that the integrity of the control system now needs to be commensurate with the level of risk. Before it was pretty vague, and just so you're aware, that now matches suit with all risk assessment standards currently on the market. And lastly, there's a requirement to evaluate and consider tamper resistance to reduce the motivation to defeat the hazardous control method. That's brand new. So knowing the design changes, it may be worth considering how your company currently specifies safety to suppliers, or even go one step further and asking your suppliers how they're designing control systems and any system designed to control hazardous energy. Do they even follow a standard? And if they don't, do you know what they do? Section 6 addresses the development of a hazardous energy control program. This applies only to the employer. OSHA 1910-147 C1 states employers must develop an energy control program, but the requirements are summed up in just a few sentences. Z244.1, this section gives guidance on how to develop the program, which in turn meets your requirements for OSHA. The section is solely dedicated to setting up and managing your program, including program elements, communication training, program reviews, methodologies, selection of control methods, and a few other things. New in the 2016 version is a subsection addressing management of change. And another thing that they added here is they changed the decision-making process for the selection of lockout, tagout, and alternative methods. It's a big deviation from the old standard, and it actually puts a lot of weight on making sure lockout is still the preferred method and pushes back to the risk assessment to determine the use of alternative methods. So knowing all this, something you might want to consider here is, how mature is your current lockout, tagout program? Does it even include an option for alternative methods? If your program is more than 5 years old, it may be worth reevaluating. Section 7, which formerly was subsection 5 of the old standard, is now a dedicated section explaining how to actually control hazardous energy at a machine level. This includes setting requirements around procedures, hardware, energy isolating devices, group lockout, complex lockout, and a few other areas. In general, this section was the most similar to the old standard, but some of the notable changes including adding elements to what's included in the lockout procedures. It also talks about increasing emphasis on verification of de-energization through testing and expanded procedures for user-directed lockout-tagout device removal. So something to consider here is a reevaluation of your lockout procedures themselves, the templates that you use. Do they include all the right elements, especially around the verification of de-energization? It might be worth comparing to this standard. Now let's talk about Section 8, Alternative Methods. A lot of people want to jump right to this information, and that's all they really care about. They want to know, how do I avoid locking out? That mindset is not the best and can get you into more trouble than good. Cherry picking certain sections misses the holistic approach and ultimately results in a less safe machine and being in a very difficult spot when attempting to explain to OSHA how you developed a good lockout program by only following one of its sections. In order to entertain using alternative methods, you need to follow the entire standard, which establishes the basis for a robust program where alternative methods is one of several options for controlling hazardous energy. A good program includes it. It doesn't jump right to it as the silver bullet. In the old standard, there were only a couple paragraphs addressing alternative methods, but now there's an entire section dedicated to it. At the very beginning, it states the requirement that there must be met before an alternative method can be used. And they require a justification analysis to make sure that the task is right. They require a risk assessment to evaluate the risks with a systematic method to reduce the risks. They require an evaluation of the hierarchy of control and an evaluation of the alternative method itself. You can't just pick a method, let's say a light curtain, and go, yep, that works for me, like you can do with general safeguarding. The evaluation of selected alternative methods is 8 pages long in itself. There is a lot to consider and questions you really want to be prepared to answer in this section. Also, there's the requirement for the alternative methods to be designed by qualified individuals. They leave that up to you to define, of course, but it is something you need to consider. So, that being said, you may want to see if your suppliers or your designers, whether they're internal or external, are qualified. The most common industry certification for machine safety design is a TÜV certification, which has a couple of different flavors that you see here. In the case of Grantek, we currently have 4 people with TÜV certifications. It's not easy to earn, but it does help explain how we're qualified to do safety design, especially in terms of alternative methods. As a reminder, the OSHA Regulation 1910-147 states that lockout is the requirement, unless you meet the minor servicing exception. So this is a case where the default is to lockout, and the burden is on the employer to show why you don't need to do it. The Z244 committee also echoes this similar sentiment. So let's review a few times where lockout may not be the best method. So these are just a few examples that under the standard may qualify for the alternative methods. Let's say you have hazardous energy that must be present because it's required to perform a task. There are times where you can't even do your task unless there's power on. Or what about lockout or tagout not being feasible or practicable? Now, feasible is an easy one to answer. It can't be done, and here's why. But practicability is more open to judgment, and that would require some very thorough explanations. Another time would be when a documented risk assessment shows that the task can be performed with acceptable risk. This basically allows you to say, I don't need to lock out because there isn't really a way that you can get hurt. This is especially valuable if you install safeguards that control or eliminate the hazards. Another example is when inherent hazards such as thermal or radiation are unable to be controlled using lockout or tagout. Sometimes lockout won't even remove the hazardous energy, like heat is an example. Another would be is when energy is required to maintain equipment in a safe state. There are times where electricity is needed to hold the machine in a safe position. And lastly, when repetitive cycling of an energy isolating device compromises the safety function. Basically, you can show that repetitive lockout is actually deteriorating your safety system. These are just a few examples, but how do you claim these or demonstrate these? Well, this is where the assessment comes into play. All of these would be documented on any industry best practice risk assessments, and they're used to help you justify why you shouldn't or can't be locking out. So in my opinion, one of the most overlooked aspects of the standards is the annexes. Annexes are technically not part of the standard, meaning that they aren't part of any of the requirements. They support the requirements through examples to give guidance. Essentially, the committee wanted to provide a bunch of useful information to help people meet the requirements of the standard. There are 78 pages in the annexes, which is unprecedented. The old version had 41 pages, and that's still more than 50% more than most other standards, so I wouldn't dismiss them. As a few examples, they include risk assessments, lockout inspection forms, management of change forms, sample justification forms, and they even have 3 different lockout tagout procedures themselves. They also even give a few examples of alternatives to consider, including on real machines with real solutions and pictures of them. One of the areas I personally helped contribute the most to standard was on the alternative methods justification template, to give the readers a simple and concise list of the things that you should be able to explain when selecting an alternative method. It might be worth considering to evaluate your current templates and documents to see how they compare to these annexes. Maybe there's stuff in there that's worth turning into a requirement because you like it. So we just went through some of the highlights of the Z244.1 standard and the impacts it can have for your organization. Hopefully you can see, if properly applied, you can help drive a safer and more efficient lockout program, which in turn will lead to lower incident rates and more productivity. You can minimize lockout points to the times where it's only necessary and have confidence that your alternative methods are still providing effective protection. Depending on the maturity of your organization's safety, engineering, and operations departments, this may be easy or difficult to implement. It really depends on how your company currently handles lockout, tagout, and machine safeguarding. However, those who are the furthest behind do potentially have the most to gain. What I'll talk about here is an overview of the main areas that really should be considered when implementing this standard throughout your organization. First is your lockout tagout program. As required by OSHA, you should already have one. The bare minimum program requirements established by OSHA really wouldn't be ready to accept alternative methods very well. You'll need to ensure you develop a process to conduct risk assessments based off of tasks and have justification for alternative methods. As part of that process, you'll need to determine your company's risk scoring criteria and what your company determines is an acceptable level of risk. Another area that you will need to consider is your machine safeguarding program, which is typically separate from your lockout tagout program. Now, OSHA doesn't require a machine safeguarding program, but as soon as you start to rely on your safeguarding as alternative methods to lockout tagout, You really need to have a program in place to ensure your safeguards are adequate and they stay effective over time. This also includes the need for risk assessments, which you might as well make it task-based and kill two birds with one stone here. You also need to establish requirements around inspection and testing of your safeguards. They can't just be installed and never evaluated again. And also training and awareness is critical. What are the hazards? What are the safeguarding measures in place? And how do these measures protect our operators? Next is safety specifications, which typically fall under your engineering specifications. This is what tells suppliers and your internal engineers and even maintenance how all the safeguards should look and feel. You'll need to specify a set of standards to make sure that you're getting exactly what you expect. This includes your acceptable methods of safeguarding, the documentation you expect to have, such as a risk assessment, and both the design and functional aspects. So for example, all e-stops must be red buttons with a yellow background. That's an example of a design requirement. However, what does the e-stop do when you push it? That's an example of a functional requirement. That may seem basic, but if you don't specify it, I guarantee in this case, in this example, your e-stops will all be different. And lastly is verification and validation requirements. These are two separate steps that ensure safeguarding methods were designed and installed correctly. You're basically asking for proof for your records. The last major area to consider is your project management process. This is very much tied into your safety specifications, but much more addresses the process for how you actually meet your safety specifications. So this includes setting up stage gates and approvals, and especially as it relates to exceptions and deviations to those requirements. So these are the main areas that you want to consider. But as you can probably imagine, this can get real complicated and intertwined real quick. Now, Grantek helps facilitate workshops to help guide companies through this process and ensure that your safety program overall is a success to all the various areas of your organization. Without a fully developed program, your only real choice for all interaction with equipment would just be to lock out. That's it. So now let's look at an example of what a lockout tagout program can look like when it includes alternative methods. So what I'm going to show you is an example. There's four possible solutions here. Lockout tagout, the need for a second protective measure, your ability to rely on the existing safeguarding, or the ability to have a permit by trained people. So in this example here, all maintenance, cleaning, and scheduled service still falls right in a lockout tagout. However, unscheduled and unplanned activities now have more options. So as you can kind of see here, there's a decision matrix where the solution or the choice depends on the current protective measure. Fixed guards or no guards, in this case, still require lockout. But depending on the reliability of the safety circuit, as shown here by different performance levels, which describe the system's reliability, A, B, C, D, or E, we can then choose to rely on the existing safeguarding. And lastly, we have live work tasks, which are required when you have a permit. So this method won't work for everyone, but it is one example of how you can make a program to be inclusive of both lockout tagout and machine safeguarding. So now that we covered the program aspects to consider, let's dive down to the machine level and look at how to approach this. To do this, I will be bringing up examples from various Grantek projects that we've done in the past to help illustrate the process, but keep in mind I'm pulling from a variety of different projects to show as much variation as possible. You will be able to see how Grantek has helped clients make equipment safe and compliant to Z244.1, but we're doing it specifically to help fit into energy control programs. By no means are these the only ways to do it, but they are a proven method and a method that you can use as one of your examples. So let's start with any machine. It doesn't even matter what you pick. I have a few examples here. It can be anything from a mixer, a machine tool, to a complicated production line. In fact, the more complex the machine is, the more the Z244.1 process will pay off. Or you can even say the more lockout is hindering your production, the more the process will pay off. So the very first step when addressing any machine is to conduct a risk assessment. This applies to machines already existing on your floor or newly purchased machines. Risk assessments are starting to become industry best practice. However, not everyone performs them. In fact, most machine builders don't unless specifically requested. Those who do perform assessments typically perform hazard-based risk assessments and not task-based risk assessments. You may be wondering, why is that? Well, if you're only addressing the guarding of hazards, then evaluating the tasks may seem unnecessary, and therefore you just look at the hazards. This results in a shorter risk assessment process and a shorter risk assessment report, like the one you see here on the left. However, to use your safeguarding as alternative methods to lockout tagout, you need to evaluate every task, or at least the task that you want to use alternative methods for. The left is a less expensive hazard-based risk assessment that only addresses machine guarding. The one on the right is task-based risk assessment, which addresses both machine safeguarding and lockout tagout. They both provide value, but for different purposes. So if you only evaluate hazards, it's hard to tell how safeguarding protects hazards or protect operators against hazards associated to certain tasks. This essentially limits you to only locking out and tagging out. A machine that, let's just say, has 6 hazards may have 40 tasks, and the risks may differ for all of those tasks because they're completely different. With a task-based risk assessment, you can now really start to see how dangerous each particular task is and come up with an individual solution, of which some of them will be lockout, tagout, some of them will rely on safeguarding, and some of them may not even require any action to be taken at all because there is no hazard to that particular task. So you may view this task-based risk assessment as more work, but I would argue that this task-based risk assessment gets you out of doing more work and allows you to use more of your safeguarding for more tasks. So after evaluating your risk for each individual task, the next step is develop a risk reduction plan. This is basically an overview of what needs to be done, modified, changed, or installed in order to reduce the risk to an acceptable level. In this particular example, we've come up with 4 different risk reduction measures for the machine and kind of grouped them together by the hazards. We then also reevaluate the risk, assuming that these measures are in place, and make sure that the residual risk afterwards ends up in a level that everyone is comfortable with. Something to consider is that when you're tackling both machine safeguarding and lockout tagout at the same time, it may be worth ensuring that all risk reduction measures are included, even if the ones that are currently existing on the equipment are adequate. This doesn't really apply to new machinery, but on most risk assessments for safety upgrade projects, only the needed changes are captured. Everything else that's good isn't documented. This works for safety upgrades to ensure the machine is safe, but it doesn't help you with your energy control program. Next, and I call this step 2.5 because it really depends on if you're upgrading a machine or if you're evaluating existing safeguards. So here I show 2 different Grantek methods for evaluating safeguards to make sure that they are sufficiently reducing risk after you're using or while you're using alternative methods. The one on the left evaluates all safeguards by specific criteria, and the one on the right evaluates individual safeguarding methods. This is really a preference, and it depends on what works best for your program and your company. The point is that there is a check to make sure that the existing solution or the proposed solution is adequate. Step 3 is unique to the evaluation for lockout tagout and the use of alternative methods. This step wouldn't normally be performed by a machine builder or integrator or supplier as part of a normal risk reduction plan unless specifically asked for. Most risk assessments that you get when you hire a company or buy a machine, like I said, are hazard-based and just make sure all the hazards are guarded. They don't typically evaluate all the tasks and suggest where you should be locking out and where you shouldn't be. That just falls on the employer to figure out. So have you ever considered asking for it? In this example, we show what it might look like. In addition to assessing the risk, we provide a second evaluation of the tasks identified in the risk assessment and compare them to the requirements of OSHA 1910-147 using the guidance that's spelled out in Z244.1. Essentially, it's going through each task and saying, Yep, that task qualifies for alternative methods. Go ahead and use it for the risk reduction measure that we have in place or that we're proposing. Or you know what? This task really needs to be locked out, even though it's the exact same safeguarding. So what you see here on the left are the specific areas that OSHA wants to see explained for tasks that use alternative methods, as well as Grantek's interpretation for those requirements. So something like saying the task must be routine. What does that mean? Well, in our case, we state that routine is any task that is considered required for production and has a defined standard operating procedure. On the right is our decision matrix, which is based off Z244.1 for how we determine what method we should use. As you can see, lockout is still a predominant choice, but alternative methods do have a slot. As a continuation of the last slide, here's just a snapshot of what an evaluation could look like for each task. So like I kind of explained earlier, if you had a machine that had 6 hazards and had 40 tasks on that machine, we would fill this out for all 40 tasks. In this particular case, with the alternative methods here, we have 4 risk reduction measures that we showed you earlier, and then we basically say whether you can use those risk reduction measures or whether you're required to lock out. So we used the decision matrix from the last slide, and then we reevaluated the tasks from several slides ago. So here you only see 4 examples for the purposes of space, but you can see the difference between the 4th one being a requirement to locking out, and the first 3 saying, you know what, that test qualifies for alternative measures. Go ahead and use that risk reduction measure that we specified earlier. So I lumped the last 2 steps together because they essentially serve a similar purpose for today's discussion, which is verification and validation. Check to make sure that everything is designed right and working right. That's essentially what verification and validation is. In this example, I skipped the actual safety design and the installation steps of upgrading or developing a safety solution because they're more for the engineers. We assume that if you are actually doing an upgrade or buying a new machine, there would be a whole project plan behind it, including the design and commissioning and startup and all the other things associated with building the equipment. So verification, like I said, is the step that checks that the safety design meets the requirements of the risk reduction plan. This is to be checked ideally before anything ever gets built or installed. Validation is a check that everything was installed and working correctly. Everything functions exactly how you said it was supposed to function, including making sure it behaves the right way in the event of a failure. Most companies do not properly verify and validate their safety systems. On the left, you can see 2 examples of verification checks, where in Grantek's case, we look over schematics, programs, device configurations, mechanical drawings, and whatever is necessary to ensure that the design is correct. On the right, we have an example validation plan. This just being one example for just an emergency stop, where we have a procedure for testing that emergency stop to make sure it functions correctly when the button is pushed. Having this documentation helps ensure that the systems in place do exactly what you expect them to do. The last thing you want is to have a safety device being used for an alternative method to lockout tagout that's providing an illusion for safety and really isn't doing what you think it's supposed to be doing. So we've covered a lot here today, but hopefully I was able to help give some insight as to industry best practices and examples of various different processes that you can consider to take advantage of increasing your safety and productivity through the new Z244.1 standard. As a general rule of thumb, and a quote that I have heard many times, the absence of an injury does not mean the presence of safety. If you don't have a written documentation explaining how your machine is safe, if you don't have that written documentation, then your machine isn't safe. At the core of the Z244.1 standard is the user and the supplier of the machinery. And the intersection between these 2 groups determines the success of the lockout system and your lockout program. Alternative methods are commonly overused in workplaces as a convenience or an excuse to not locking out. In those cases, they're often poorly thought out and poorly resourced. Alternative methods done correctly demonstrate the necessary precautions that may be taken to ensure that you have a safe place of employment through a well-defined combination of engineering controls and administrative controls. And that ultimately results in not only a safer work environment, but a more productive work environment. So Grantek can help. They can help you on your journey throughout this process of becoming world-class in safety. Whether you're starting from scratch or making incremental improvements, we can help. We provide thought leadership at the corporate level through facilitating the development of specifications and the building of programs, all the way down to the machine level, where we conduct assessments, we develop risk reduction plans, we create safety requirement specifications, we do turnkey remediation and updates, we include safety design and engineering, we do site surveys, and even develop templates, procedures, and checklists. Let us know how we can help.